Okay, so as you see, we have defined my sales call priority here as an attribute, and automatically that attribute is equal to 0 by default, but anybody who goes to this assign module, it is going to be changed to 1. And in this seize module, the order status callers are going to ask for seizing a sales agent. So the resource they would like to seize is a sales agent, and the queue that they are going to enter is going to be the process sales call queue here. So at this point, they are going to share the same queue as the process sales call process. And now we have the queue spreadsheet view here, and from the queue spreadsheet view, we have changed the queue discipline of the process sales call queue to the lowest attribute value by looking at the my sales call priority. So if your my sales call priority remains at 0, then you are going to be given the priority. Otherwise, you are going to get behind in the queue. Okay, and if a new person enters in the queue with a lower priority than you, then they are going to get in front of you. Okay, so that's it basically. Then after that point, my friends, what can we do? Now, once these clients, callers, who can seize an sales agent after this seize operation, they are going to enter a delay process. They are going to enter a delay process after seizing that sales agent. They are going to enter a delay process, and that delay process can be introduced by, again, a process module here, or maybe we can use another thing from the basic process panel. So let's do that. So let's erase this one, and instead, after this seize operation, I'm going to introduce a delay operation, and the name of this delay is going to be delay for order status conversation, delay for order status conversation with salesperson, So after seizing that person, we need to delay that person, and the delay time is going to be triangularly distributed with which parameters? Let's see the parameters again. The distribution is going to be 3, 5, 10 with triangular distribution. 3, 5, 10. And in minutes, of course. So we need to change the unit in minutes. And this is going to be a delay for order status conversation with salesperson. And after this delay, my friends, after this delay, we are going to release the salesperson. So from the advanced process panel as well, you can create a seize delay release operation instead of a single process. So the trick here is this. If we have two processes which are sharing a common queue, then one of the processes, you need to write it in the form of a seize module, delay module, and release module. Okay, if you expand one of these processes like this, then from the seize module here, you can define the shared queue name, and you can direct the entities who enter this process to that queue. Okay, so one of them should be written in the seize delay release queue. However, if you would like to use seize delay and release modules all the time, you can use them in any way. So instead of defining processes directly with the process module, you can define all processes with a sequential seize, delay, and release modules. Okay, so this would be a low-level programming approach, not low-level, but a lower-level programming approach. Now here we are going to name this release process as order status call releases salesperson. So order status calls, release the salesperson. I mean, if you write it like that, this is just going to be label, right? So this is just going to be label. What I need to do is what? I need to name the resource that I need to release. So I add here, the resource that is going to be released is going to be which resource? The sales resource. And how many I am going to release? Of course, one, because I have seized one. Okay. I mean, if you seize one resource and release two resources, then there will be an error in the programming, right? So I need to release that one sales resource that I have seized earlier. Now, another thing that you can do here is this. For example, you can seize two resources at a point. Then you can release one of them at one point and another one in after another process. Okay. So if you seize multiple resources, for example, you can release some of them at a location and other one of them in another location. Especially in distribution network simulations, this is a good idea, right? So here we are releasing only one sales agent. So I say one sales agent is going to be released. And after this release operation, the process is going to end and that callers are going to leave the system as well. So let's just define the exit of this system now. Now you see I have this process, this one, and the true answer for this decide module. All these guys are going to directly to the exit. Okay, they are going to leave the system, but before leaving the system, what they need to do is they need to release their trunk lines, right? So remember in the beginning, I have seized the trunk line. For everybody that enters into this system, they seize a trunk line, and therefore they need to release that trunk line as well. So I am just going to add another release module here. Okay, choose release and another release module here, and that release module is going to be named as release trunk line. Release trunk line, and which resource that I need to release? This time I need to release the trunk line. So the number of units of trunk line that I release is again going to be 1 because every caller is seizing only one trunk line. Okay, now I am just going to click on the connect button, but this time I'm going to teach you something. I am going to make a double click on it. Double click on it. Now, if you double click on the connect button, so I don't know if it works or not. Yes, if you double click on them, then you do not use the connect option, not just once, but you can use for all of them. Okay, so I'm not clicking on this connect button again and again, as you can see. So every customer coming from all of these processes are going to be directed to exit, but before they exit the system, they are going to release the trunk line. So the number of trunk lines, available trunk lines, is going to increase by 1. But this is not the only thing that we need to do before the exit. So the next thing that we need to do is what? Now, if you see what have we done here, in the beginning, we have seized the trunk line, and after seizing the trunk line, we are increasing the active call numbers. So number of active calls or the variable total WIP is increased by 1. Now, before leaving the system, we need to decrease it by 1, right? So after releasing the trunk line, I am going to introduce another assign module here and connect that release trunk line to that. And I will name that assign module as decrement active call counter, decrement active call counter. And here I am going to change the variable. Which variable? V total WIP, which I have created, with a new value. The new value is going to be V total WIP minus 1. So this means subtract 1 from that value and update it. Okay. And okay. So I click on OK here. And one final thing that I need to enter before the exit, I am just going to record the completed calls. So record completed calls, I say. And here again, I define a counter statistic. And this is going to be increased by 1 with every entity moving through this record process. And the name of this counter is going to be completed calls. Completed calls. Completed calls. And then I click OK. Okay, now if we do that, the simulation will be complete. There will be no remaining exit. Everything is going to be disposed. Now let's just try to run a slow simulation of this system. But you see we get an error. Okay, so it is actually, okay, the problem is I have written infinity here at earlier. I think it is just a wrong statement, so I'm going to close this. So when I create a create module here, infinite, I need to choose infinite here, not infinity. So this was wrong. I have done this mistake yesterday actually. Okay. So I need to write infinite here. Okay, we have written that. Now if I run my simulation, I get another error. So what is the error? It says order status delay. We have triangular distribution 2, 3, 4, order status delay storage, undefined symbol, order status delay storage. All right. So that's the problem. So remember, I have told you in the previous hour, so let me close that. I am in this delay module, I am naming a storage ID here. Automatically a storage will be created and disposed when an entity enters into this delay process. And the name of that storage is going to be order status delay storage. However, as you remember, when I check the storage module under the advanced process panel, I do not see the name of that order status storage. So I need to enter that name here. The problem is this. I need to manually enter that name. Otherwise, we are getting an error. So I have entered the name of that storage here. So that storage will be defined. And automatically, that delay process is going to understand which storage they are using. So now if I run my simulation, again, I get another error. So it says a linker error was detected at the following queue. Queue process says call queue. Queue number 4 is already assigned, it says. Well, it may be very impossible for me. So we have process says call queue here. And when I check the queues from the basic process panel, I can check the queue spreadsheet here. Actually, there is not a queue number 4 here. So I have said that they need to change the process sales call. The queue name should be process sales call queue. So let me check the same part in the book as well. So the new queue name should be process sales call queue from the top down list. And we choose the lowest attribute value for that queue. Now, why do we get an error? Process says call queue number 4 is already assigned. So here in the queue process says call, so we have the edit via dialog box option here. So you see we have a queue which is called process says call queue, and the queue discipline is lowest attribute value, but I haven't clicked on shared. So that's the thing. This is a shared queue. It's a shared queue, so I need to click on that. That's the problem. Now I think I'm not going to get any error. Yes, the simulation is running. So let's explain the details of the simulation now. Let's see the animation. Let's watch the animation. Now I'm just going to make it as visible as possible. So you see the arrivals, the callers are arriving. Right now, up to this point, 15 calls have entered the system. Okay, so 15 calls have entered the system. Then they have, okay, so there is a problem, I guess, here. Okay, it's not a problem. So you see the callers are arriving here in the system. Now you see some queues here. In these three processes, you are going to observe some queues. Now let's make it faster, especially because a large percentage of customers would like to get a technical support related to process, related to product type 1. We observe a large queue here, and you see there is another queue here. Please check that queue out. So the beautiful thing about this queue is what? So the beautiful thing about this queue is this: green balls are always in front of the blue balls. The green balls are in front of the blue balls always. Why? Because we are giving priorities to sales call as the callers who would like to get sales information. Okay? So the blue balls are always behind the queue. So the priority issue that is practically working here, and we can understand it by the animation because we have changed the colors of the balls here to green and red for respective customer types. Okay, and you see the simulation is going to continue. How many customers could have entered the system? Now, because of this 26 trunk lines capacity problem, you see up to this point, approximately 25 or 26,000 people have entered the system, but 4,300 people could not have entered the system. Maybe we should increase the number of trunk lines. So according to the simulation results, how many of the clients could have entered the system? Actually, a very large percentage of them could not have entered the system. Okay, so the percentage of the people, the callers who could not have entered the system is actually very large. Okay, now you see we have a shared queue here. Now we also have what? We also have the delay storages here. So you see how many people are. So let me slow down the animation a little bit. So anybody who wants to enter here is entering in recording delay here. So sometimes we see one people there, sometimes we see two people there. Similarly, we have other delay processes here. So you see right now two people are listening that recording delay. Right now one people is listening that recording delay. Right now nobody is listening that record. So the size of the queues are observable here. You can create many animations to understand the system better.